Our next exercise is called triangle area calculation. And I'm just going to copy the prompt into Jupyter Hub over here. So we'll put that there where the exercise goes. And then I will just format it a little bit better. And as before, ChatGPT suggests a formula, and I mean, I guess we all already know that this is the right formula for the area of a triangle. One warning though, if ChatGPT suggests a formula to you, you do want to do a little bit of due diligence generally. It does turn out sometimes it could suggest formulas that make absolutely no sense. If that happens, you can always try arguing with ChatGPT. It's really happy to try and have an argument with you. It may not learn anything from the exchange. Okay, so write a program that calculates the area of a triangle given its base and height. Now, again, it says prompt the user. I'm just going to say start with, again, because we know that we haven't yet learned how to prompt the user for anything, and we may not want to learn that now. Now, if you do want to learn that now, you can actually ask ChatGPT to help you. You can say, how do I prompt the user for something? And or you can fast forward and look at the videos for, I don't know, like week 4 or week 6 or something. Okay, but in the meantime, we'll just start with the values of the base and height as floating point numbers. So this is significant. In the previous exercise, we had to read between the lines a bit and decide that we needed to use type double because we were going to work with fractional data. If this bit of the exercise weren't here, I think we'd still make that assumption. So we'd still say, hey, you know, the area of a triangle, the formula actually involves multiplication by 0.5. So that's a good sign we probably want to use floating point variables, so float or double. But here the exercise actually says it. And one good bit of practice is, like you'll have to worry about on an exam, if the exercise says to do something, you have to do it, even if you don't think it's a good idea. So here it says use floating point numbers. It doesn't say which type to use. So floating point could be float or double. And as I said in the last exercise, I'd say it's better to default to double. So what I'll do is, as my input, I'll just create two variables called base and height. And I think what I'm going to start with is setting the base and height to 1.0, because then, just as a very basic test of my program, I should expect the area of the triangle to just be 0.5. And that way I can test out things like, is my output being generated correctly? So I'll say double area equals 0.5 times base times height. And you'll notice I'm actually using the formula verbatim the way that it's written here. Maybe I would write it in a more aesthetically pleasing way, so maybe I do, I don't know, 0.50 or something. But if the exercise says to use this formula, I really shouldn't make any other modifications beyond small aesthetic tweaks. So what I shouldn't really do here is do base times height all over 2. I should actually multiply by 0.5, even if you, like me, think that it's better to write over 2. It just looks better. I'm going to leave it in the format that I was given. And then I'll just print out, so the area of a triangle with base, and I'm just going to use again %.2f. Although in an exercise like this, you could also just use %f with base %.2f and height %.2f is, and then I'll print out the finished area. Okay, so there's base, there's height, there's area. And now I can test this out. So I'm expecting the area to come out to be 0.5. So we'll do that. Practice variables, there we go. And the base is 1, the height is 1, and the area is 0.5. All right. One thing I'm not really getting into here is we haven't been given units for these measurements. So we're not told, are the base and height in millimeters or meters or something? I'm not concerned about that for this case because we're used to using, geometrically, we're used to having unitless measurements. So we're assuming that we're working on the Cartesian plane or something. If we were talking about something more realistic, so if I was talking about velocity or something, then I would expect ChatGPT to give me units. And if it didn't give me units, I would go back and argue with it until it did. But here we already know that we can compute area without necessarily having any units of measurement unless it's actually working with physical areas somewhere. So now my testing. How do I make sure the program actually works in general? Okay, well, there are a couple of things I want to do here. So I could try setting the base and height to different values. And I mean, I guess the first thing that comes to mind is, what if I have a base of 2? And this is, I don't know, a little bit risky. So maybe you can see the problem that I'm going to have here, which is if the base is 2, then the area is going to be 1.0 because I've just multiplied the whole formula here by 2. I ought to do a lot more testing than that. Let's try a base of 4. And if I look at the formula, I should expect it to come out with an area of 2. And you might be looking at this and sort of yelling at your screen, like, why am I doing all of this testing? Isn't it obvious? Yes, to me it is obvious, and to you it's probably obvious. Even after only a week of programming, it's probably obvious. That doesn't mean that testing is a bad idea. The point of testing is to prove what you already know. Even when something's obvious, you test it, because that way there's no chance that some tiny little typo showed up that resulted in your code making a mistake. All right, so here, area with base 4 and height 1 is 2. I also ought to test out what happens if I change the height but not the base. Now, we know that those have the same impact on the formula, so the output should be the same, but notice how here it says base 1 and height 4. I've seen a lot of people that write programs that are that have errors in them that aren't an error with the calculation itself, but instead an error with the way that things get printed out. And so often you'll get people that write programs by accident, even I have done this, where it always prints that the height is 1.0. They just forget to sub in the real value of height. That's why we test. I think it's also worth trying out what happens if I use a base and a height that are both fractional. So let's do 1.5 and 1.5. And so, okay, out of my head, 1.5 times 1.5 is 2.25. So I expect the area to be 2.25 over 2, which is 1.125, I guess. I probably ought to plug that into a calculator if I'm going to do complicated. Okay, so it looks like it's base 1.5, height 1.5. The area is that. Should I be concerned about this? It's 1.12 instead of 1.125. Well, I don't know. It's hard to tell. So if I'm really worried that this number might be a mistake, the first thing I would do is go and actually produce this calculation myself on a calculator. Maybe I've made a mistake with my calculation in my head. The next thing I want to do is I'll remove the 0.2f. I want to show maybe more digits of decimal precision. And it looks like when I have more digits of precision, it does come out as 1.125. And so here what's happening is it's decided that it's going to shorten the number down, and it just eliminates that extra decimal place. And it ends up not rounding it up, it rounds it down. And it's a bit of a mystery the way that the rounding behavior works at this point. It's a topic that's actually surprisingly complicated, so we won't get into it right now. But here it is pretty clear it is computing the right area. My program is doing what I want it to do. And I wouldn't know that unless I tested it. I can have all the confidence in the world, but just staring at the code and saying it should work isn't enough. Okay, let's try at least one more. So I'm going to see what happens if I do a height of 2 and a base of 1.5. I should expect here, of course, that what I get is an area of 1.5. And so there it is. Okay, one last test case. What happens if the base is 0? So unlike in the previous example, I'm not going to test on negative base or negative heights, on the logic that I don't think a triangle should be allowed to have a negative height or a negative base. That doesn't make any sense to me. And so I don't need to test on things that will never occur, unless somebody forces me to. So the assignments occasionally say, you still have to handle this. But unless it does, nobody should be computing a negative, the area of a triangle with a negative height. And if they do that, it's sort of their problem if the answer comes out and it doesn't make any sense. So here I'm going to try a base of 0. In my opinion, with my math background, I sort of think that a triangle is allowed to have a base width of 0. Similarly, it's also allowed to have a height of 0, but it can't go negative. So I'll try a height of 0. And I expect this to come out with an area of 0. And it does. Okay, so I think that this program now works. I think I've tested it pretty well. It's still possible that it has a bug, but I've done enough testing to verify that if it does have a bug, it's a pretty unlikely bug to occur. The most embarrassing bugs are the ones where you give the program to somebody else and literally every test they do, it fails. That's pretty embarrassing. So I've done enough testing that I don't think that's going to happen. And so therefore, I think it's about time for us to move on to the next exercise.